That's ambiguous ASS triangles. Oh, darn it. It's still lagging. Okay, so ambiguous ASS triangles. Sounds a little bit weird, but here is the idea. If you remember in geometry, you were not allowed to use ASS as a triangle congruent property. What that meant is that if you were given an angle side-side, if I say 32 degrees, and I give you guys the side, let's say 10 and 8, ASS, you could not say this is for sure 100% guaranteed to always look like this. You can't tell me it's always going to look like this. And here's the reason why. Because I want you to think of, let me turn on my camera real quick. Everyone look at my camera. Can you see my camera? Let me put spotlights on me. Okay, so look at my pencil here. Do you see how it's swinging back and forth? I want you to think of this last side 8 as almost like a pendulum that will swing back and forth. Because did I tell you what angle that has to be? This could be over here. This could be anywhere I want, essentially. Now that looks a little bit weird, but there's actually a gimmick to these types of triangles. There's really a big fat gimmick. And the idea is that if it's angle, long, short, ASS, meaning a long side and a short side, you're stuck with this dilemma. And the dilemma is that this could be the triangle you're looking at, or it could look like this. That is still 32, 10, and 8, but it's just the smaller version of the triangle. That's still 8. That still fits this 32, 10, 8 triangle, but now we have 2 possibilities. And here's the reason why. Let me show you guys practically why. If I drew a circle around this like that, okay, well, that was terrible. But if I drew a circle, something like this, 8 is the radius. So it turns out there are actually 2 places that it hits this base. So it gives us 2 possibilities. And who are you to judge which one this is supposed to be? Is it supposed to be the fatty or the cutie? All right. So here's what we end up with. We end up with 2 versions of this triangle. Let me draw this again. We have a triangle that looks like what we thought, 32, 10, and 8. But then we have the other triangle that goes this way, and it's 32, 10, and 8. And this triangle is really in this guy, but going this way. All right. So this is the problem with ASS triangles. You don't know which twin you're going to get. I'm a twin, remember? So my name is Edward. So my brother's name, if you don't know yet, is Edwin. Right? So if you say, hey, Ed, you're not sure which twin you're going to get. If you say, hey, Edward, got it, that's me. If, hey, Edwin, that's him. But if you say, hey, Ed, and I had some lazy friends, I would just say, hi, Ed, because they didn't want to take the time to memorize which twin this was. Great friends. So we are going to solve it today this way. Now I'll show you how they're related in this bigger version right now. So angle, okay, side, side. Now, darn it, I'll do this triangle a little bit off. Has to always look kind of short like that. This is the long side and then the short side. There is one cool property here. The second triangle is actually pretty easy to find. And all it involves is 180 degrees. So to solve this problem, we would use, let's see, an angle side pair. This would be law of sines. So if I use law of sines, call this A, B, and C. If I use law of sines to solve for A, what angle would I be able to solve for given little c? Law of sines always helps me find angle side pairs. If I have an angle side pair, it helps me find the other pair. So if I have this side, here's what's going to happen. It's going to lead us to find angle C. Once we find angle C, my first step is to find angle C. We're going to use this to find this angle for my new second triangle. All right, that's our pathway to solve these triangles. So let's go ahead and give ourselves an example. So again, first step for these, always solve for this opposite angle that we have. And then that's when we can break into two triangles and we can solve for the second triangle that we have. So let's go ahead and give ourselves an example again. Just like what we did before, let's use the triangle that we had before. We said 10, 8, and 32. So let's go ahead and solve for C. A, B, C. So to solve for C, we have an angle side pair here, so we know we can use law of sines. So we need to figure out angle side pair. That means we can solve for angle C. Set this up, sine of C over, in law of sines, if you remember, we write the angle over the side. Sine of A over A. Sine of B over B. Sine of C over C. So we have sine of C. We're going to copy side C in. This is side A. This is side B, which you don't know. Over 10 is equal to the pair that we do know, sine of 32 over sine, not sine, just 8. Over 8. Use your calculator. C is equal to, let's go ahead and jump to my calculator. So for the test, all the work that you need to show is this initial setup. If you show this setup, you've shown the work. Everything else is calculator work. So I'm going to type 32 sine times 10 equals, divide by 8 equals, we end up with a decimal. We're going to go undo sine. Angle C is 41 point, let's do 2 decimals, 48 degrees. So we know 41.48 degrees. So since we're here, let's solve for the rest of the triangle. Okay, we know 2 angles. We can find the third angle. Because how many degrees do all triangles add up to? All add up to 180. So 180 minus 32 minus 41.48 gives us our third side, 106.52. Once we find our third angle, we can now find our third side. Again, back to law of sines. B over sine of what angle? 106.52, because it's the opposite angle of B, is equal to the pair that we know, 8 over sine of 32. Multiply sine to both sides. 8 times 106.52. Sine that equals, and we're going to divide this by 32 sine equals. B is equal to 14.47. 14.47. Now, you could say you're done, but honestly, you are only half done. Because when we're asked to solve for the triangles, we're asked to solve for all the possibilities in this dimension as well in our alternate dimension. So here's our second triangle. Second triangle, let me show you guys how to get to that second triangle. It's actually super easy, so don't freak out. So let's draw the triangle again, and we'll see what do we know. We know this is 32. We know this is 41.48. 8, 10, A, C, B. Okay. Now, the second triangle, remember, we mentioned was going to be cut. So I'm going to draw my second line right here. Because if it's 8 here, hey, this looks like 8 also. And it forms this triangle now in blue. So I'm going to highlight this triangle in blue. And this is the new triangle we're solving for. Now, here are some geometry skills. If you have a triangle that has the same exact leg size, an isosceles triangle, what can you tell me about their angles, corresponding angles here? If one is 41.8, the other one is actually the same thing, 41.48. But if we're solving for the blue triangle, is this angle 41.48 inside the triangle or outside the triangle? It's outside. See you later, Roman. We would have to subtract 180 from it, and that's how we end up with this angle. So the hint is to get from your original triangle to the new triangle, you just have to subtract 180 from it. Let me go through the motions again. Why is this true? First, if you tell me one side is 8 and the other side of it is 8, this is what we call an isosceles triangle. Great. So if you have one angle, you have the other angle. Now, isn't this second angle bumped up next to the angle I want? And that is a 100-degree line. So if I subtract it from 180, it leads me to my inside angle. Now here's the fast trick, just minus 180. Or maybe the other way, 180 minus the angle. So I'm going to go 180 minus 41.48. This gives me 138.52. I now know two angles inside my new triangle, my alternate triangle. Super important for you guys to see that. Now, let me draw this triangle now for you. The triangle looks like this. We have 32, 138.52. We know only two sides, and we're missing our last angle side pair. So how do I find this angle here? Given two angles already. Don't they all add to 180? So 180 minus 138.52 minus 32 gives me 9.48 left. That's why this is a little tricky of a strategy. You need to be able to find both different triangles, and we're only given information from one triangle. But every time we find some new information, it leads us to the next step. So now that I know my third angle, I can find my third side. A, B, C. Oops, other way around. A, C, that's right, B, C. So we're going to find B now for this new triangle. So here we go. B over sine of 9.48 is equal to 8 over sine of 32. If you just joined us for the class just now, this looks very terrifyingly hard. What are you doing? All I'm doing, remember, is filling out our law of sine rule. Sorry, it's A. Just filling out the parts. Angle B, side A, angle A. I'm just filling it out. Everything else is calculator work. B is equal to 8 sine of 9.48 over sine of 32. You do not need to write this. This is good enough work for me to save you some time. But you have to know how to use your calculator. 8 times 9.48 sine equals, and divide that by 32 sine equals. And we're left with b is equal to the little tiny side, 2.49, rounding up. 2.49. Okay, so this is in general how we solve for our two ambiguous triangles. Whenever you see ASS, you might be in trouble. Do all ASS triangles give us two possibilities? Answer is no. If a triangle goes angle, short, long, there is no way for you to make another triangle. You can't just make a small cut because this is too long. These are not the same sides. So if it's angle, short, long, there's only one possibility. Angle, short, long. For an ASS, remember this is ASS triangle? One triangle only. Super important to note. This is just these small random rules, but logically it should make sense. Is there any way for me to spin this side around? No. Let's do one more example. I'm going to do it from your homework this time. So your homework, you're going to see problems like this typically, and this is a problem that we worked on before. But then this one here, they're going to have you draw triangles out in which they don't have the triangle already drawn for you. Okay, so please be aware, they didn't draw the triangle for me, so I'm going to have to draw it out myself. So for this problem, okay, so I'm going to have to label all the parts myself and recreate this triangle. So using law of sines, find all triangles if angle A is 47, side A is 34, and side B is 35. Okay. So here we go. I'm gonna draw a triangle like I did before. I'm gonna call this 47. The side opposite of 47 is angle A. It's side 34, because these are opposite sides. And then I can call the side next to me, we'll call that 34. Oh, 35, I'm sorry. So this is B, little b, A, little a. So we have to still find angle C and side C. Okay, so before I fill these out, this triangle says obtuse and this one says acute. So I won't know which one is which until I find out both answers, then I can fill it out. So looking at this, I know 1, 2, 3 bits of information, and I know this is law of sines. Also, this is an ASS triangle, angle, long, short. So for sure, either this triangle doesn't exist or I have two versions of it. So let's go ahead and solve it. If I have angle side A, I'm given side B. I need to look for angle B now. Sine B over 35 is equal to sine 47 over 34. All this is calculator work. What am I going to type in the calculator? Sine of B is equal to 35 sine of 47 over 34. That's all calculator work. 35 times 47 sine equals then divide that by 34 equals. Now that's a decimal number. That is not an angle. I need to undo my sign. B is equal to 48.8. How many decimals do they want? Do they say? I think there's only one decimal, 48.83. Oh, it doesn't ask for a lot of decimals. Okay, so I'm just giving myself one decimal. Okay.
Wait,
so
Mr. Ko.
Yep.
Why did you use negative sign?
Because to get rid of the sign here, I had to do sine inverse to both sides. So 35 times 47 sine equals divided by 34 equals, wait, 34, yeah. And they give me a decimal. That's not an angle.
Oh, okay.
So I have to
Gotcha.
undo my sign to get that 48.8.
So whenever you get a weird angle, bam, sine
Yeah.
inverse.
Well,
Okay.
also, if you look here, it's not b by itself. There's sin in front of it. So stop sinning.
Uh-huh. Okay.
Oh, it says round to the hundredths. I'm sorry. I didn't read that. So rounding to the hundredths. Oh, I see now. Thank you. Right there. It says round to the hundredths place. Thank you, Christian. Thank you for reading. So I'm going to say 8-4. Sorry. Okay, now that we found the second angle, we can go ahead and finish this initial triangle. I'm going to go 180 minus the other two angles I know. I know 47, and I also know 48.8, which I just found. My last angle is angle C has to be 84.2. 84.2. Whoop. Sorry. I should rewrite that. Be 180 minus 47, then minus 48.84, and that's 16. My bad, because I didn't round off to nearest hundredths. 84.16. Now I know my third angle. I can find my third side using the easy law of sines. So we can write C over sine of 84.16 is equal to 34 over sine of 47. Sorry, I got lost on which was my original calculator work. 34 times 84.16 sine that equals, we divide it by 47 sine. That's all just calculator work. And so C is equal to 46.25, rounding up. 46.25. Now, which triangle was this? The obtuse or acute? An obtuse triangle means there's a fat angle bigger than 90 degrees. All these angles, 84, 48, and 47 are smaller. So they actually want us to fill it in here. So angle B is 48.87. Angle C is 84.16. And side C is 47.25. Now, I'm going to draw my second version. So that's my original. My second version, remember, gets cut. So we still have 47. We still have 35. We still have 32. 34, I'm sorry, 34. A, C, and B. But now, since we knew this angle over here was 48.87, we steal it by 180 degrees. 180 minus 48.84, that was 84. That becomes 131.16. Now that's an obtuse angle. That's pretty obtuse. So we have two
Mr.
angles.
Ko,
We can find the third. Yep.
was angle C, I got 84.13.
I got 16. Oh, here's a mistake. This was 84 right here. That was 84. That's why.
Oh, I put 87.
Yeah, it's because my terrible handwriting. Sorry.
Okay.
So once we have the new angle, we can find our third angle here. Just like what we did before to find this 84, we do the same thing now to find our new C because we found angle B. So 180 minus 47 minus 131.16. And this is a really tiny angle, 1.84. So essentially, you're just solving for two triangles now, except there's a special way to get to that second triangle. So last part C, C over sine of 1.84 is equal to what we know, 34 over sine of 47. Calculator work, 34 times 1.84 sine equals, divide that by 47 sine equals, we end up with a side, C is 1.49. 1.49. Okay. 1.49. 1.84 for the angle. And side B is 131.16.